Hello students, and welcome to today's lesson on vectors. Take out your textbooks because we have a lot to go over today. Today you will learn to identify vectors and use vectors to solve real-world problems. To begin, we must first be able to identify what a vector is. Does anyone here know what a vector is? How about you, Andrew, since you're raising your hand?
Me?
Is there anyone else here named Andrew?
According to my definition of vectors, a vector is any quantity that has a magnitude and direction, especially when determining the position of one point in space relative to another.
Very good, Andrew. I see you can look things up on a dictionary. You are correct. But in mathematics, a vector can be visualized as an array with an initial point and a terminal point, as seen here. We can also find the horizontal and vertical components of a vector. That is, how far left and how far right, plus how far up or how far down a vector will go. So, here represented on the x-axis is the horizontal component, because it is moving in a horizontal motion. The vertical component is on the y, because it is moving in a vertical manner. Now, we're going to do a practice problem to see if you can identify what a horizontal and a vertical component is. Let's take this triangle. It has an initial point of 2, 2. Shoot, I messed up. 2, 1 and 5, 5. Now, to find these 2 points, how do you think we identify them?
Well, maybe we could take the x and y value of the initial point and subtract it from the x and y of the terminal point.
Correct. So we're going to subtract 2 from 5 and 1 from 5. That'll give us 3 and 4. This can also actually be written as a component form, which will be 3, 4, because that is the horizontal component and the vertical component. Now we can actually find the magnitude, which is how far this vector is going to go. And how do you think we can do this?
I know this is a crazy guess, of course, but it looks like the vertical and horizontal components, they kind of form like a right triangle with the vector, and the vector is almost like the hypotenuse of a right triangle.
Very good, Andrew. Very intuitive of you. Seems like you've had a good teacher.
Yeah, his name is Mr. Nguyen.
Never mind, back to the lesson. If we envision the vector as a right triangle and the hypotenuse is the direction and magnitude of a vector, we can use Pythagorean theorem, just like you said. Now, to find the magnitude, we're going to rearrange the Pythagorean theorem equation. So we're going to take these 2 points, which are the component form, and we're going to say that the magnitude of the vector is the square root of 3 squared plus 4 squared. Now, if we write that all out, we see that the magnitude of this vector is 5.
But teacher, I mean, think about it. Like, vectors, what's the importance of vectors? Like, they're really just a line on a graph. Like, what significance does it have to anybody, like, in the real world?
Andrew! What do you want to do in life?
I guess I have an interest in, like, aeronautics and aerodynamics.
What you don't realize, but which I hope you can learn from today's lesson, is that vectors are much broader than you can imagine. They can be used to calculate the ground speed of an airplane, the force of a car moving on a highway, the ideal angle of shooting a basketball.
Wow, honestly, I'm just kind of blown away right now, teacher. Like, I didn't realize how applicable vectors are in our everyday life, let alone the fact that they truly are the basis of physical life. And at this point, I'm just really intrigued, and I just want to learn so much more about vectors, and I'm ready to get into today's lesson.
Hi guys, thank you for watching our introductory video on vectors. I hope you can use this resource to further your understanding on vectors and hopefully learn something more about vectors.